Okay, everyone, welcome back. This is part 3 of the lecture for chapter 5. This one shouldn't take too long. This is dealing with estimating probabilities. And, I don't have that many slides left to go through to show you this. But again, this is estimating probabilities and dealing with the normal curve. Again, it shouldn't take too terribly long to get through this portion of the lecture. So there we go. If you will, make sure. Okay. All right. So a probability is basically described as the chance that certain events will take place. We deal with probabilities in our daily lives all the time. For instance, we consider the chance of rain or the chance of probability of getting a speeding ticket if we drive over the posted speed limit. We consider that. That's a probability. What's the likelihood that I'm going to get a ticket if I get pulled? What's the likelihood that first I'm going to get pulled over and then I'm going to get a ticket? To estimate probability, what we end up doing is we divide the number of successes, okay, the number of successes divided by the number of events. All right, that's not the neatest, but you get the point. The number of successes divided by the number of events, all right? That's essentially what probability is, all right? So probability is, if you're trying to do an equation for probability is equal number of successes, I'm just gonna do an S, divided by the number of events, all right? I don't know that the book has that in there like that, but that's essentially what probability is. All right. So consider the King of Hearts. I think the book, oh, let me back up real quick. Probabilities can be expressed as a fraction, as an odds ratio, or as a proportion. And remember, you looked at, excuse me, you looked at that stuff. I believe it was chapter 2. Yeah, I think it was chapter 2 when you looked at percentages, proportions and ratios and all of that type of stuff. So you've already been exposed to some of this. You've been exposed to proportions already. And that's essentially how we deal with probabilities as it relates to the normal curve. Again, in social sciences, we tend to gravitate toward expressing probability as proportions. So an example that I want you to consider or think about is the King of Hearts example. Okay, so with the King of Hearts, and I believe this is in your textbook, but with the King of Hearts, there's only one King of Hearts in the deck of 52 cards. So one King of Hearts out of 52 cards. So maybe we want to know the probability of pulling the King of Hearts from the deck, and that probability is 1 out of 52 because we have a full deck of cards. There are 52 cards. The success that, our success of pulling out the King of Hearts is 1 because there's only one King of Hearts in the deck. Well, what are the number of chances or the number of events? There's 52. So 1 out of 52. Now we could leave this as a fraction, but since we work more with proportions, what we'll do is actually convert the fraction to a proportion by dividing the numerator, which is 1, by the denominator, which is 52. And we get 0.0192, okay? That's how we would express that in terms of probabilities. All right, now, this right here is, we're gonna basically look at an example, okay, using, trying to, like with z-scores or whatnot. Yeah, so what you might want to do is take a moment to write this information down because I'm actually going to go through this example on the next slide. So in this example, the mean is 13, all right? The standard deviation is 4. And what we want to know is what's the probability of selecting a score of 19 or more, all right? Now I put a portion of that question in bold. That portion, selecting a score of 19 or more, that lets us know that we're looking for a score above the mean. So remember, in lecture 2, in part 2 of the lecture, when I was going through and talking about, figuring out what the scores are, and this is again where drawing this stuff out comes in handy. So let's say you draw this out, okay? All right, I'm not gonna go through and draw the x-axis and all that stuff, but just know that this is what we have. So maybe what we want to know, what's the probability of, so our mean is 13. We want to know, well, what's the probability of randomly selecting a score of 19 or more? Well, what we know, because if that's 19, we know that we're looking for a score above the mean. All right. We're looking for something above the mean and above the mean only. If let's say the question asked, well, what's the probability of randomly selecting a score of 12 or below? Then we know we want something below the mean. But let's say the question asked us, well, what's the probability of randomly selecting a score between 12 and 19? That's when we have a score, like we're looking for something between two scores that are on opposite sides of the mean. And remember, that's what I was just showing you in the previous lecture. Now I'm going to do it one more example. Let's say that we have a score of 50. Ooh, that's not very pretty, but you get the point. Let's say we have a score of 15. And the question was, what's the probability of randomly selecting a score between 15 and 19? Well, we know that these scores are on the both on the same side of, they're on both sides. They're both on the same side of the mean. So those steps that I took you through earlier, when I showed you all of that, that's where that stuff comes in handy, okay? And this is where reading and looking at the questions carefully is beneficial, because when you read them carefully, it will give you an idea of what you need to look at. All right, so here's the information from the example. The probabilities in proportion form are randomly, the probabilities in proportion form are already stated in the normal curve. That's Appendix A, okay? So, that's basically, that is the areas in Appendix A can be interpreted as probabilities. They're already in proportion form. And remember, the way that we tend to look at probabilities for social sciences, we usually express probabilities as a proportion. So they can already be interpreted as a probability. Now, to determine the probability that a randomly selected case will have a score between X and the mean, we convert the original score to a Z-score. Next, we use the normal curve table, Appendix A, to find the area that is being looked for and its corresponding probability. Now, using the information from the previous slide, this is why I said go ahead and write it down. But in case you didn't, what I will do right quick is, if I can find my little, okay, there we go. Okay, remember that the mean is 13. So I'm just gonna write M equals 13. Then the score, Xi, is equal to 19. And the standard deviation, S, is equal to 4. Just in case you couldn't remember, in case you didn't write it down. All right. So using that information from the previous slide, we're going to find, first we find the Z-score. All right, so to find the Z-score for this, I basically, Z is equal to, I'm going to do parentheses so that I know I'll keep things separate. And remember that formula for Z-score is Xi, okay? Let me write this somewhere. I'm going to write this down here. Okay, folks. So down here at the bottom, I'm going to do the formula for a Z-score. Remember, formula for a Z-score is Xi minus the mean divided by S. All right. So there's that formula in case you need to see it again. But since I'm not going to write it vertically, I'm just going to write it in one line. I'm going to put the top part in parentheses. So Z is equal to 19 minus 13, because remember, X is the score, 19 is the score, the mean is 13, all right? And we're going to divide that by 4. Well, what that comes out to is 6 divided by 4, which is equal to 1.5. So I have a Z-score equal to 1.5. Well, here it is over here. I have it highlighted and I have the number highlighted in red. All right, so here's that Z-score, okay? There's the Z-score. Now, remember what the question was on the previous, excuse me. Let me back up. Again, if you didn't write it down, it is what is the probability of randomly selecting a Z-score of 19 or more? 19 or more, all right? That's key, because what that's telling us, we want to know the area above the mean, or we want to know the area above the Z-score. Okay, I keep saying mean, but what I mean is we want to know the area above that Z-score. And we know that that Z-score is when we take this 19, because remember, that's what we converted. When we take that number right there, we converted it into this Z-score of 1.5. So we come over to the table, we look at the 1.50, and we want to know the area above. Remember, column C tells us the area beyond the Z-score. And in this case, that's what we're looking for. And if I had drawn out the normal curve, well, I drew it out on the previous slide. Oh, I guess I'll go ahead and draw it out real quick. Remember, again, it helps to draw this stuff out, okay? So remember that our mean is 13 and the score that we were looking at was 19, and everything we want is above that. So we know we're on the positive side of the mean, okay? But we also know we want everything that's beyond that Z-score. And that's what this tells this right here, the 0.0668, that's what that tells us. We know we want to look in column C. So we can say that the probability of randomly selecting a score of 19 or more is 0.0668. Because we just want the probability, there is no need to convert that into a percentage. All we want is the probability. If we wanted the percentage, we would multiply by 100, and then we'd know that it was 6.68%. But we don't want that. For this, we just want the probability. All right, so what this is here is just kind of like giving you pointers and tips. This is also in the book, in the textbook as table 5.4, and use this to help guide you when you're using the procedures for finding the areas above or below Z-scores. Again, I will continue to say this. It helps to draw the curve and shade in the areas you're interested in. So remember, if you're trying to find the area above the above the Z, look in column C, okay? If it's positive and you're trying to find the area above the Z, okay, you look in column C. Okay, 1 second, I'm trying to, okay, I was gonna try to draw these out for you, but there we go. All right, so remember, area above, there we go. Area above the Z. This is the area above the Z when your Z-score is positive. All right, so positive Z-score, let's just say my mean is 10. And my z-score, excuse me, not that, my z-score, remember this is the theoretical, and I'm looking at 1 standard deviation above. So I know that I want everything beyond that area, okay? If my z-score is negative, because remember, a negative z-score means it's below the mean. So then I'm looking at, okay, let me do this. That works a little better. If whatever I'm looking at is a negative z-score, excuse me, my apologies. I just did that backwards. Ignore what I just said. Let me start this over. So we're going to erase all of this. Let's do this again. My apologies. All right, so if I'm looking at the area above the z, and that area, my z-score is positive. Okay, so if I'm looking at the area above the z, okay, here's my normal curve or whatever. Let's see here. And whatever it is positive. That means it's on this side. My z-score is positive. It's on this side of the mean. Let's say my z-score is 1.5. Uh-oh. Let's say it's 1.5. All right. And I want to know everything beyond that 1.5. I look at column C. All right. Now, if I have another z-score, all right, and that z-score is negative, so that means it's on this side of the mean. So let's say it's a negative 1 point, well, not negative 1, well, you know what I mean, negative 1.5 standard deviations, whatever. That means I'm looking at everything and I want everything above that z-score. I'm looking at this area plus this area. Okay. All right. I hope that makes sense. All my scribble scrabble, hopefully it makes sense. Remember, if you have a positive z-score, all right, a positive z-score, that's what we have over here. This is a positive z-score. So positive 1.5. The z is equal to 1.5. It's positive, whatever. You know that you just look in column C for anything above the z. If it's the opposite and it's a negative z-score of 1.5, but you still want to find everything above the z, you look at column B and you add that area from column B to that 0.500. All right, so I'm going to erase this now. Now, if you are looking at something and it's below the z, all right, so we're dealing with the positive, a positive z-score. Okay, there's something at the bottom of my screen that won't let me write that. So just know that line, that's your mean. But let's say you have a positive z-score of 1 point, I think one of our examples from before was 1.67. All right, but you want to look below the z-score, but it's a positive z-score. So you know you got to find this area, which is your area between the mean, okay, and the z. So you take this area and you add it to 0.500, because remember, 0.500 is all of this. All right, this right here, that right there, that's that area in column B. All right, so that's where you take the area that you find in column B and you add it to the 0.5000. And that's how you get, when your z-score is positive and you want to know what it is, what the area is below the z, that's how you do that. Now, if say, for example, Your z-score is a negative 1.67. And you want to find the area below the z, and it's negative. That's all of this right here. And all you do is look at column C. Okay? Again, hopefully my Scribble Scrabble is helpful. If it's not, just ignore it, but hopefully it's helpful. Yeah, I hope it helps. All right, so, I accidentally went backwards. All right, still going backwards. Hang on, you guys, my apologies. Okay, now this is that one where I was talking about finding the areas between the scores, okay? If you have, like, these are the situations. If you have something where, all right, so if you have something where your scores are on the same side of the mean, so this is the first one. Okay, here's your mean. And so here's score 1. All right, let me draw this in a different, do this in a different color ink. So let's see. Okay, so let's say that score 1 is in red, okay? And then we have another score. Score 2, let's say that score 2 is in cyan, whatever this blue is. Okay, there we go. Hang on, you guys. Lost my pen again. There it is. Okay, so let's say that this score 2, so we'll do x2, x1, okay? Remember to find this area, so this area right here, I'm doing it in this little cyan looking blue. I'm scribbling on the screen right now. This is the area we're interested in, all right? What you have to do is take, look at the score and the mean in column B for both of them. You subtract the smaller area, okay? You subtract the smaller area from the larger area. So in this instance, you would subtract x1 from x2. So I'm not gonna write a formula because what you need to remember is subtract the smaller area from the larger area, all right? But before you do any type of subtraction, you need to find the areas in column B. Then you do the subtraction, okay? Now, if you have, let's see here, okay. Uh-oh. All right, so let's say that you have scores on opposite sides, all right? I actually kind of showed you this already once, but I'll do it again. Let's say you have a distribution and the question is asking you, oh my, just go with it, folks. Just go with it. Okay. All right, so let's say that you have a score on one side of the distribution. So we'll go back to our different colors. So let's say X1, okay? And I'm just gonna leave them the same color. I don't feel like going through and messing with the pen. And X2. You find the areas between each score. So you find this area here, you find this area here. And remember, the way we find the score between the mean, the way we find the area between a score and the mean is by looking at column B, okay? And you just add the areas together. That's essentially how you do that. So that's just kind of a recap, me drawing out the different ways to do these things. And this is why I say drawing this stuff out is helpful. Again, yes, my drawings are scribble, scrabble, they're horrendous, whatever. But you get the point, okay? All right, so again, points to remember, cases with scores close to the mean, those are gonna be common. And the scores that are far from the mean are rare. Those are typically your outliers. And the normal curve is essential. It's quite helpful when it comes to understanding part 2 of the textbook. This is where we start to get into hypothesis testing and all of that type of stuff. So that concludes the overall lecture. This is part 3, concludes part 3, which concludes the lecture for chapter 5. As always, as I always say, if you have questions, you can email me. You can put your question in the Ask the Instructor chat box. You can, you know, visit me during my office hours, whatever you need to do. If you have questions, you need clarification. If it's clarification of something in the book, or if there's something that I said that doesn't make sense, just seek me out and contact me and we'll figure it out. All right, take care and have a nice rest of the day.